Hello, my name is Shashank Shekhar and we have started the first chapter of chemistry, class 11, that is basic concepts of chemistry. Okay, so in the first chapter, we have discussed about the introduction part, that how chemistry was developed as a discipline of science and how it came into the picture that can help all the people in the daily application thing. Okay, we also discussed how Indian culture and the science was deeply blended, and in India chemistry was called as Rasayan Shastra, Ras Tantra or Ras Kriya. Then we have seen that many excavation and many findings showed that chemistry and Indian culture are deeply blended. Later on, we discussed about matter, that what are the three states of matter, which are solid, liquid and gas, and what are their properties. Then we discuss about classification of matter. So this is a chart from the previous lecture which I put here to just to give you a quick recap on it. So this is the matter. So matter can be classified into two. The first one is the mixture and the second one is the pure substance. So what is mixture? So mixture is something in which two or more pure substance are mixed in a amount that is not validated, and it is variated each time it is done. Okay. And later on, the mixture can be divided into two, that is homogeneous mixture and heterogeneous mixture. So what is homogeneous mixture? In homogeneous mixture, the constituent are mixed thoroughly, means its concentration or composition remain same throughout the system. You can consider the example of sugar dissolved in water properly. So it will have the same taste, which can illustrate that it is a homogeneous mixture. The second one is the heterogeneous mixture. For heterogeneous mixture, you can think of air. So in air, the oxygen gas is present, nitrogen gas is present. So if you measure the quantity of this gases present in one place as compared to the quantity present in other place, it will vary. So it is a heterogeneous mixture. Now second is pure substance. So what is pure substance? So pure substance is something in which the constituent particle are mixed in a fixed amount, means it composition is fixed. So if you consider water molecule, then it will of course have two hydrogen only and one oxygen only. It will not be the case that three hydrogen and one oxygen will make a water. Similar case goes for oxygen molecule. So oxygen molecule has two atoms of oxygen. So pure substance can be divided further into two things, that are elements and compounds. So what is the difference between element and compound? The first difference is that element have the same constituent particle. So oxygen molecule is an example of element because it has oxygen atom as the constituent particle only. The second one is compound. So in compound, two or more constituent particle, different type of constituent particle combine to give a compound. So for the example is water molecule, which is having two hydrogen atoms and one oxygen atom. Another example is carbon dioxide, which has one carbon atom and two oxygen atom. Whereas the example for element is an oxygen molecule or a hydrogen molecule. I will now move to the today's lecture, which is about the properties of this matter, okay, and how they can be measured. So when we talk about the properties of a matter, there are mainly two types of properties, means they can be broadly divided into two. The first one is the physical property and the second one is the chemical property. Okay, so there are two types of properties of matter, that is physical property and chemical property. So what is physical property? So first of all, whenever you look at a matter, you can classify many of its properties just by seeing or smelling it, like the odor, the color of that. Then further, you can also measure the length using a ruler. So these things which can be done directly without altering the identity of that matter, those properties are called the physical properties. Other example are boiling point. So boiling point is also a physical property, density of that matter. So we will talk about density in the upcoming slides. So these all properties are the physical properties. Okay. Now next we will move to the chemical property. So what is chemical property? So suppose you have to define whether a matter is combustible or not, means it can catch fire easily or not. So that the test of combustibility is a type of chemical property, that whether it is combustible or not. So suppose you take kerosene oil and then you take water. If you burn the both, you will find that kerosene catches fire easily, whereas water doesn't catch fire. Okay, so you can say that kerosene and water compared, when compared, the kerosene is more combustible as compared to water. But it is a chemical property because while testing their combustibility, you have changed the identity, because while you burn the kerosene, it gets converted into carbon dioxide and water. Okay, water vapor also you can say it. Then reactivity with acids and bases. So it is also a chemical property, because when we react something with something, we get a new thing that does not have the identity of the previous reactants. Okay, so suppose you take an acid and react it with base, it will give salt plus water. So reacting acid with base gives salt plus water. So suppose you want to get the chemical property of this, so you react it with the base and get salt plus water. Now the products formed here do have chemical properties that are completely different from its parent products. Okay, parent reactant. Okay, similar case applies to acidity and basicity of the matter. Now, what is the importance of physical and chemical property? So physical and chemical properties are very important to classify a matter. So whether a matter that you are going to use is acid or base, it is whether tough or not, whether it will has the required color or not, whether it will react with water, whether it will not react with water. So you need to classify that matter properly, so that you can get the idea of whether to use it or not. So chemical and physical properties are very important to classify substances. Now, these physical and chemical properties are applied so well to make our daily need things very easy. Okay, so let us consider utensil, the utensils which are used for cooking. Okay, so what is the first requirement that you want a utensil that so that it can be used for cooking? What is the first requirement that can be made? Okay, so first should have a high boiling point or a high melting point. I can say for solid it should be a melting point. So it should be have high melting point, means when you put it on fire it does not melt easily, because you want to cook food. Okay, so it should not melt easily. So for that, suppose we take iron, we can cook food in it. But what does the drawback that come with iron is it is rusting. You must have seen then when iron is exposed to open air, it get rusted or get corroded with time. Okay, and it get destroyed. So to avoid that, iron is mixed with chromium and an alloy is made. So what does chromium does? Chromium react with oxygen and forms a protective layer, so that it can be avoided with further rusting. Now, you must have heard about stainless steel. So stainless steel is an alloy of iron plus chromium plus carbon and many more elements. Okay, so you can see how physical and chemical properties are applied and things are made which are very important for our daily life, like the utensil, like the heater we used. It has the wire that is also an alloy and it's the property best suited for cooking purpose. Okay, now let us see how the physical properties can be measured. So to use a thing properly, you must have the basic requirement, that is the measurement of the physical property. So how long or how short should it be, how which color should it have, that so that it can be used in a place. So to measure the physical properties, there are some standards that are well developed in the world, so that there is no confusion from one country to another. So suppose you want to measure a room, then you would use a ruler for that. So what does ruler have? So if you take a ruler, you can see the readings present in it. Okay, the readings are present on the ruler, and this gap between this is defined for all the ruler and is same for all the ruler. So this certain length gap is used and measured. The length of the wall is measured. So if you say that suppose the length of this wall is 3 meter, then for me it will be 3 meter, and for other also it will be the same 3 meter. So this kind of system exists, so that there is no confusion in case of length. Okay, now earlier two type of system existed. The first one is the English system. Okay, and the second one is the metric system. Okay, these two systems were used in different parts of the world, but metric system was much more accurate. Why? Because it uses the decimal system added to it. What does decimal system does? So suppose the length of something is 33.33 meter. Okay, and you measure it without decimal. What does it give? 33 meter. And now suppose you measure another thing, that is 33.36 meter. But without decimal, it will again give 33 meter. So as you can see that this system is more accurate because it includes decimal with it. So the metric system has this advantage. So it was more convenient as compared to the English system. Okay. The system which exists in today's world is the International System of Units, or the SI units in short. We will use this SI term for the rest of our lecture. Okay, so this is the modern form of the metric system. So it is the modern form of the metric system, and it was created with signing a treaty with CGPM, an intergovernmental treaty organization. Okay, so it created the metric convention. Now, what is CGPM? So CGPM is the Conference on Weights and Measurement. So in the 11th General Conference, an intergovernmental treaty called CGPM organization created the Meter Convention, which was signed in Paris in 1875. And it is the most used system all over the world and accepted all over the world. So here is some detail about it. So the Meter Convention is a diplomatic treaty that aims to establish and maintain worldwide uniformity in measurement. Means it confirms that the measurement should be acceptable all over the world and there should be no confusion regarding its uniformity. And CGPM is responsible for maintaining and updating the SI system. So what the CGPM does? It upgrades the SI system according to the current requirement. Okay. Now we will move to the SI system. So there are seven base SI units. Okay, the seven base units of the SI system. What are those? The first one is meter for length. The second one is kilogram for mass. The third one is second for time. The fourth one is the ampere for current. Kelvin for temperature. Mole for the amount of substance, and luminous intensity candela is used. Okay, so these are the seven base units, and using these units most of the things are measured, like the speed, like the acceleration. All of the things are using this measured using this seven base units. Okay, now we will move to derived unit. So all other units other than the seven base units are the derived units. Whether it will be the speed, it is the derived unit, or it is the acceleration, it is the derived unit. So there are many derived units in the SI system. So how is the speed a derived system? So what is the formula for speed? It is distance per unit time. What is the SI unit of distance? You can see here it is meter. Okay, so you will write it meter. What is the SI unit of time? It is second. So it will be meter per second as it is written here. Okay. Now consider another example, that is acceleration. Okay, acceleration. So what is the definition for acceleration? It is change in speed. I am representing change with delta per unit time. Okay. Okay. So what is the derived unit for speed? It is meter per second. And what is for time? It is second. So what is the final derived unit for acceleration? That is meter per second square. And for speed, it is meter per second. So you can see that base unit can be used properly and derived units can be derived for the various other quantities. So now we will talk about some of the units, some of the properties of matter, like the mass, the weight, volume, and many more other things. So first we will clarify you the difference between the mass and weight. So many of you must have been confusion that what is the difference between mass and weight. So what is mass? So mass is basically the content of the matter that is present in an object, or the amount of a matter present in an object. That is the mass, and it is uniform throughout the universe. So whether you measure a mass of something on Earth or on a different planet, suppose it comes out to be 2 kg, then it will be 2 kg all over the universe. So some mass is something which is constant, and the SI unit of mass is kilogram. Now I have put up a picture here of a analytical balance. It is used to measure the mass of something which is very small like chemical or something which is used in laboratories. So this thing is used in laboratories for accurate measurement. Okay, so the measurement which we do, it is not accurate because and it will alter the composition also. Suppose you want to measure something which is 0.002 gram. Now, if any dust particle is added to your compound, it will alter the precision and may change the mass of that substance. So, for that, this delicate instrument is installed in laboratories so that you can measure the accurate mass of that compound or the element you are dealing with. Now, what is weight? So, weight is just the force of gravity acting on an object. Yes, you heard it right. It is a kind of force. So, what is the formula for weight? It is mass into acceleration due to gravity. This acceleration due to gravity may vary from place to place. So, if for Earth, its value is 9.8 meter per second square. Okay. You can also measure the weight of this anything using this formula. And the SI unit of weight is Newton, as the SI unit of force is also Newton. Okay. Now, next we will go to volume. So if you think of a matter, when you place that matter anywhere in the space, it will occupy that space, and that space is the amount of space is called the volume. Okay, and it has the units of length. So we will see how it is the unit of length. So the SI unit of volume is cubic meter, and meter is the unit of length. So I have said it that it is the unit of length. Then what is 1 cubic meter? So you consider, suppose you consider a box. This is a cubical box, okay, and its height is 1 meter, width is 1 meter, and breadth is also 1 meter. So if you find the value of the volume, then it will be 1 meter multiplied by 1 meter into 1 meter. So it will be 1 meter cube. So in this way, we can define 1 meter cube by taking a cube which is 1 meter in length, breadth, and height. Okay. Now we will move up to the commonly used unit of volume, that is liter. So whenever you go to a shop, or you go to take milk from somewhere, or you go to take oil, the unit that is commonly used is liter, that 1 liter of milk. So this is the common unit that is used. Okay, this is a 1 liter cube that is mentioned here. So 1 liter is equals to 1 decimeter cube, means the length of this cube, means the length, breadth, and height of this cube all are 1 decimeter. So when you multiply 1 decimeter into 1 decimeter into 1 decimeter, means the volume can be calculated using multiplying the length, breadth, and height. You will get it 1 decimeter cube, and that 1 decimeter cube is 1 liter. So 1 liter is equals to 1000 cubic centimeter, because 1 decimeter is equals to 10 centimeter. So if you put 10 centimeter here, 10 centimeter here, and 10 centimeter here, you will get 1000 centimeter cube. As you can see here, that 1 liter is equals to 1 decimeter cube is equals to 1000 centimeter cube. So it is a commonly used metric system in our daily life, which we use for measuring the liquid in our daily life, like milk, kerosene oil, or edible oil, or water also. Now, we will move to the measurement of volume. So in laboratory, these things are used to measure the volume. So you can see here the readings are present on this tube. It is a test tube. Okay. So the ml is used here because the thing that we use in laboratory are generally in small in quantity or very less in quantity. So you use smaller units like milliliter to measure those things. So it is milliliter. So you can see here that the division is put here out 10 milliliter, 20 milliliter. Similar case goes for this pipette. Okay, this is a pipette. You will come to know what in the laboratories. Okay, this is a conical flask of 1 liter. Okay, this is a burette. So burette is used for titration. You will study the titration in the very first experiment only. So these things are used in laboratory for the measurement of volume. Okay. Now, now we will talk about density. So what is density? So density is the way we can define that how closely the molecules are packed to each other. So suppose you take a iron and you take a wood, the same volume will give you the different mass. Why? Because the amount of atoms that are present in a iron are closely packed, due to which it will have a greater mass as compared to the wood. So what the density is generally the measure that how closely the particle is packed in that crystal or solid or liquid. Also density can be measured for solid, liquid, gas, all. Okay, the definition of density is mass per unit volume. Okay, now you will move to the SI unit of density. So to find the SI unit of density, you have to divide the mass into volume. So what is the SI unit of mass? You must have seen in the earlier time that the SI unit of mass is kg, and the SI unit of volume is meter cube. So it will be kg per meter cube. So you can see here that we can derive all the derived unit using the base units of SI system. Okay. So these 7 base units will be always used to measure all the derived units. Okay. So here is an example that the density of water is 1 gram per centimeter cube. This means that when we take a cubic centimeter of water, then it has a mass of 1 gram. Means if you take a cube that is 1 centimeter in length, 1 centimeter in breadth, and 1 centimeter in height, and you completely fill it with water, then the water contained in it will have the mass of 1 gram. It is a very interesting thing. You can use it for everything, and in the daily life it is used also. Okay, so this is the illustration of density. Next, we will move to the temperature. So, you must have heard this word temperature in everyday life. That okay, today the temperature is high, today the temperature is low, today we are feeling hot or cold. So, temperature is just a measurement of how hot or how cold a thing is. Though, so various systems are there for measuring the temperature. The most common one, which we always heard of, it is Fahrenheit and Celsius and Fahrenheit. So every time you measure the body temperature, you use the Fahrenheit scale, which is in which mercury is used as the compound for measuring the temperature, and the thermometer thing is used for that. Okay, the thermometer is filled with mercury and it rises and shows the Fahrenheit scale. The first one is the Celsius scale. So Celsius scale is calibrated from 0 degree Celsius to 100 degree Celsius, and 0 degree Celsius is the melting point of water, you know it, and 100 degree Celsius is the boiling point of water. Okay, now if you compare it with the Fahrenheit scale, so 32 degree is Fahrenheit is the melting point of ice, and 202 degree Fahrenheit is the boiling point of water. The next one is Kelvin scale. Although this Kelvin scale is not used in our day-to-day life, but it is the most scientific one, because in every scientific calculation that we do in our books or in our labs, they all are based on this Kelvin scale. So it is the absolute temperature scale. Okay, which means it does not have a negative value. Means you cannot have a negative value of Kelvin. Mean you cannot have -2 Kelvin. It is not possible to have a -2 Kelvin. 0 Kelvin is the lowest possible cold. Okay, so it does not have a negative value. For that reason, it is called absolute. Means the value which are taking can never have a minus or a negative sign before it. So here is the measurement scale for all those three. So here the boiling point, it is 373 in Kelvin, 100 degrees Celsius, and 212 degree Fahrenheit. In the human body temperature, room temperature, freezing point of water, and this three is the you can compare those three using this diagram. Okay. Now next we will move to the relationship thing. So for the system of measurement, you need to convert one thing to another and get the value that are useful at different places. Okay. So if you want something that is small, then you need a small measurement system. If you want something that is large, then you would need a large system. Okay. So the Fahrenheit is related to Celsius in the following way. So 1 degree Fahrenheit is equals to 9 by 5 degrees Celsius plus 32. Okay, this is in this way you can convert the Fahrenheit into Celsius thing. The second one is the Kelvin scale. So in Kelvin scale, we can convert the Kelvin into degree Celsius using this relation, that is 1 Kelvin is equals to degree Celsius plus 273.15. We will see this illustration in the coming slides. So suppose the temperature of water at which start boiling is 100 degrees Celsius, and you want to find out that what is it in Kelvin. So you know the relation that Kelvin is equals to degree Celsius plus 273.15 Kelvin. Okay. So suppose here the boiling point of water is 100 degrees Celsius. So we put here 100 degrees Celsius plus 273.15 Kelvin. Okay. So this will give you 373 Kelvin, which is the boiling point of water as mentioned here also. Okay, this is the relation. Now you want to convert it into degree Celsius to Fahrenheit. So how you will convert it? So we know the relation that degree Fahrenheit is equals to 9 by 5 degree Celsius plus 32. Okay. So you can convert it into degree Celsius. So we can write here that 9 by 5 into 100 degrees Celsius plus 32. So it will be 20 180 degrees Celsius plus 32. It will be 28311 and it will be 2. It will be Fahrenheit. You can see here the same is written here. So this is 212 degree Fahrenheit. So you can measure the change the one unit to another using this relation. So thank you for today's lecture.